Let's go ahead and work a couple problems where we use logarithmic differentiation to find the derivative. So this is one of those topics in math where it's very much of a niche kind of process, but sort of interesting and not too difficult for you to learn. Let me give you a few reminders about some log properties that we're going to use, and then I'll work a couple problems. First thing you need to remember, we're talking natural log here. Here's a rule for natural logs. If inside the natural log, you're multiplying, in this case, like two factors, you're multiplying two things, you can rewrite that as the natural log of A plus the natural log of B. So anytime you're multiplying factors inside of a log, you can separate out each of the factors and then just add them together. So you'll see when we start working the problems, we'll be using this property. And another property if you have inside of a log an exponent, in other words, a base with an exponent, you've got that really cool rule with logs that if you have an exponent inside the log, you can move the exponent out front as a coefficient. So when we work out these two problems in a couple minutes, you're going to see that we use both of these sort of log rules. And then there's one more, even though we've been just covering what we call implicit differentiation. Let's remind ourselves how that applies if we have a natural log. So say we have a natural log of x, and we're going to take the derivative with respect to x. So natural log of y, we're looking to take the derivative of this with respect to x. So if you remember the way I taught implicit differentiation, it's almost like follow the normal rules for your log, but then you have to tack on, in this case, the dy dx. Since the variable in your expression is different than the variable that you're taking the derivative with respect to. So the derivative of natural log of y is just 1 over y. However, because my variable is y here, then you also multiply by dy over dx. And actually, this is really the whole key, because what's going to happen is once we have this dy dx, then we're actually going to solve for dy dx, because if we solve for dy dx, then that theoretically is the derivative. All right, 3 reminders of things that we're going to be using as we solve these problems, and don't think you'll find them too difficult. Now, in terms of using logarithmic differentiation, it's pretty easy, because typically in instructions and the homework, and if it's on the test, usually they say use logarithmic differentiation to find the derivative of this equation. So they pretty much tell you up front to use it. So it's not like you have to decide, oh, should I or should not use it? Should I or should not use logarithmic differentiation? So here's a pretty messy equation. X squared plus 4 raised to the 10 power times 2x minus 5 raised to the 8th power. We basically want to take the derivative of this equation. Now, I guess you could, if you were not going to use logarithmic differentiation, you could use product rule combined with chain rule. It could get sort of messy, it's manageable. But instead, we're going to use logarithmic differentiation. So what you do in logarithmic differentiation is, I actually could put steps here. It's assumed when you're given a problem, you have y by itself, and the other side you have a bunch of x's. That's how you always start. First thing you should do, you take the natural log of both sides of the equation, right? And then roll the math. You can do anything you want to an equation as long as you do the same thing to both sides. So we're going to take the natural log of both sides of this equation. Now this first problem, I'm going to try not to skip any steps just so you can follow what I'm doing. The second problem, I'll combine a few of these steps. I'm going to say use natural log rules to break up. You know what? I'm going to use this highly technical term. Break up the messy side. I mean, the messy side means the side with all the stuff on it. I mean, this side's pretty straightforward. So what that means is, first of all, this log rule, when you have things multiplied inside a natural log, you can break it up. So what I'm going to do is this first parenthesis and the second parenthesis, I'm going to think of like separate functions. And because they're multiplied together and inside the natural log, I can break them up. So it's going to be natural log of x squared plus 4 to the 10th plus natural log of 2x minus 5 to the 8th. All right, so I simply applied this rule that I reviewed up here. And now actually I'm going to apply this other rule where if you have an exponent inside of a natural log, you can bring it out front. So what I'm going to do is, maybe I'll save some time here. Instead of rewriting the whole thing, I will just bring the 10 down front and bring the 8 down front. Now the third step is to take the derivative of both sides. Right, remember when I said you can do whatever you want, as long as you do the same thing to both sides of the equation. But now we're going to take the derivative of both sides. That's going to be a derivative with respect to x. So once again, let me not skip any steps. The left-hand side, derivative of natural log of y. Right-hand side, let me go ahead, since it's two separate terms here. See if I can squeeze it in here. So in a sense, up here you have three terms. So you take derivative of both sides, take derivative of all three terms. And now it's going to take the derivative. Now here, derivative of natural log of y is pretty straightforward. It's 1 over y, but because the variables are not the same, you have to tack on the dy dx, right? That's what I reviewed up here. It's called implicit differentiation. Now on the right-hand side, the 10's a coefficient, it comes out front. So we have the derivative of natural log of x squared plus 4. This is where we use sort of a chain rule, because derivative of natural log says you put 1 over whatever's inside the natural log, and then you multiply it by the derivative of what's inside the natural log. Derivative of x squared plus 4 is 2x. Then for this last term here, once again, the 8 is a coefficient, comes out front. Derivative of natural log of 2x minus 5, where you put 1 over what's inside the natural log. And then you take the derivative of what's inside the natural log, which would just be 2. So I'm going to do two things. I'm going to go and do a little simplifying here. Then also I'm going to multiply both sides by y, because I multiply both sides by y, then I'll have the derivative by itself. So this is 20x over x squared plus 4 plus 16 over 2x minus 5. So now in a sense, we've determined the derivative. Dy dx is this. Although there's only one problem. When you do this, you want the variables on the right-hand side to only be x. Right now, I've still got a y here. So what can I do with this y here? Where you go back up the original problem, and y is this here. So I'm going to take all of this stuff and plug it in for y down here. So when you do that, then the answer really gets messy. So y was x squared plus 4 to the 10th power, 2x minus 5 to the 8th power. That's just the y. And then multiply it by 20x over x squared plus 4 plus 16 over 2x minus 5. Wow. I'm just checking to make sure they can make mistakes. I'm worried about this. Let me check the answer in the book, because once again, I hate to do a problem and then have the answer be wrong. I want to find my mistakes. So this is, I believe, this looks like this number 37. Let me just check. I hope I didn't make any mistakes, but it's happened before. Yeah, so this is actually correct. So that's good. All right, so not horribly difficult, a little messy, some algebra, some log rules, taking derivatives, but hopefully you do a few of these and get the hang of it. Let me just do one more. This one I may go through a little faster. I may skip some steps as I'm careful. I don't have to write as much since these are pretty messy problems. All right, so here's another one. Y equals x plus 7 to the 3rd times 2x minus 5 raised to the 6th power and x cubed minus 2x plus 1 raised to the 7th power. Now, if you tried to take derivative of this, sort of using normal rules, it would really get messy because they have 3 products. So power rule, oh my, I almost makes that hairy. So I think what you do is have to do power rule this times these. You almost have to do the power rule on the first 2 or these 2, and then redo the power rule. Wow. So this is a case where this logarithmic differentiation is probably actually going to be easier. So first thing you do is, I'll just write it up here. Take the natural log of both sides. Now over here, I'm going to split this up into these 3 factors. And also I'll go ahead and bring the exponent down front. So this one's going to be 3 natural log of x plus 7 plus 6 natural log of 2x minus 5 plus 7 natural log of x cubed minus 2x plus 1. All right, so this is using those 2 log rules. Now, take the derivative with respect to x of both sides. Left-hand side just becomes 1 over y dy dx. Right-hand side, so we can do this. So the 3 is a coefficient. Derivative of natural log of x plus 7 is 1 over x plus 7. Derivative of the inside is just 1. So this first one should be 3 over x plus 7. Second one, you're going to have a 2x plus 5 in the bottom. 2x minus 5 in the bottom of your fraction. You're going to have a 6. And then the derivative, what's inside here is just 2. So it should be 12. Derivative of this last one, the denominator is going to be x cubed minus 2x plus 1. So the top, you're going to have 7 times the derivative of what's inside here. Well, this is 3x squared. Minus 2. Now, the last step is going to multiply both sides by y. So when I do that, let me go ahead and replace the y with my original big messy. So actually, I'm going to try and write the final answer. So the original y is x plus 7 cubed, 2x minus 5 to the 6th, x cubed minus 2x plus 1 to the 7th times 3 over x plus 7 plus 12 over 2x minus 5. I'm going to multiply out these parentheses because I think in the answer they did that. 21x squared minus 14 over x cubed minus 2x plus 1. Now, just to confirm that, of course, that is very messy. Make sure I didn't mess up. X plus 7 cubed, 2x minus 5 to the 6th, x cubed minus 2x plus 1 to the 7th, and then times 3 over x to the 7th, plus 12 over 2x minus 5, plus 21x squared minus 14 over x cubed minus 2x plus 1. That looks correct. All right, so pretty messy problem. And by using this logarithmic differentiation, we were able to actually get the derivative. So, all right, not too bad. Hopefully when you get the homework or the quiz, you can do these correctly.